Let's do some calculations using the arithmetic series formula. Now we're supposed to evaluate this series. What is the meaning of this? It means we have to find the sum of 5 minus 3n from n is equal to 3 up to n is equal to 50. Okay, so what we do, let's find just our first three terms so that we can get our a and d. Let's find our first term. Remember, we substitute this number into the general term to find the first term. So t1 is equal to 5 minus 3 times 3, which is negative 4. 5 minus 9 is negative 4. And then we substitute the next natural number after 3, which is 4. So t2 is 5 minus 3 times 4, which is equal to negative 7. Then t3 is equal to 5 minus 3 times 5, which is equal to negative 10. Now it means our first term is equal to negative 4, and then our difference, common difference, will be negative 7 minus negative 4. Negative 7 minus negative 4, that is negative 3. Even if you say negative 10 minus negative 7, that will be negative 3. It's like negative 10 plus 7. Right. And then the number of terms. Remember, we say top number minus bottom number plus 1. So it's going to be 50 minus 3 plus 1 from the sigma symbol here. So it's going to be 50 minus 3, 47, 47 plus 1, 48. Now, this is an arithmetic series because there's a common difference. So we're going to use Sn is equal to n over 2, then 2a plus n minus 1d. Let's substitute what we have. Sum of 48 terms from the number of terms equal to 48 over 2. Then 2 times a is negative 4. And then plus n minus 1. N is 48, so it's 48 minus 1. We can just write 47 there. 48 minus 1 is 47. Then the common difference is negative 3. Put it in the bracket. We can put this in the calculator. What do we get? Sum of the first 48 terms would be negative 3,576. Okay, let's do example 2. Determine n if this series is equal to 354. So what is the meaning of this? We are adding 5p minus 3 from p is equal to 1 up to p is equal to n to get 354. So it becomes, then where there's p, you put 1, becomes 5, and then 1 minus 3, that's the first term, plus the second term, 5 times 2 minus 3, plus the third term, 5 times 3 minus 3. It goes on like that till we substitute n. So it's 5 times n minus 3, then is equal to 354. Right, so it means here we're adding 2 plus 7 plus 12 plus, it goes on like that till we have 5n minus 3 is equal to 354. So from here we can see that our a is equal to 2, our d is equal to 5, and number of terms is equal to n minus 1 plus 1. Top number minus bottom number plus 1. So meaning that this is n. Number of terms is n. Okay, don't forget to find the number of terms every time. Okay, so it becomes Sn is equal to n over 2, 2a plus n minus 1d. Then Sn, sum of these terms is 354 is equal to n over 2, We're looking for n, isn't it? Then 2 times a, which is 2, then plus n minus 1. The difference is 5. Then let's simplify this. Let's multiply by 2 on both sides of the equation. Just want to eliminate this denominator. So it becomes 708 is equal to n, then 4 plus 5n minus 5. Right, we can simplify this. 708 is equal to n, then 5n minus 1. 4 minus 5 is negative 1. Then we can remove the brackets here. 708 is equal to 5n squared minus n. Right? Let's write it in standard form. 0 is equal to 5n squared minus n minus 708. Sometimes it's difficult to find factors for such equations. You may use the quadratic formula. So n is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. Then n is equal to, and then b is what? B is negative 1, so it's going to be negative 1 plus or minus the square root of b squared, negative 1 squared minus 4. Our a is 5, then our c is negative 708. All this over 2 times a, our a is 5. Then you can use the calculator here, okay, that n is equal to 12 or n is equal to negative 59 over 5. N should be a natural number, so this is not applicable. Always check your n. Always check your n here. So the number of terms here is n. So therefore n is equal to 12. Okay, let's go to example 3. If this series is equal to 20 and 1 over 6, let's find the value of k. Right, so this means that we're adding 1 over 3p plus 1 over 6 from p is equal to 0 up to p is equal to k to give us 20 and 1 over 6. So it's going to be like this. And then it's equal to, where there's p, put 0, 1 over 3, 0, plus 1 over 6, and plus 1 over 3, 1, plus 1 over 6, then plus 1 over 3, 2, plus 1 over 6, and plus, goes on like that till you get to 1 over 3k plus 1 over 6 to give us 20 and 1 over 6. Right, so it means this will be 1 over 6 plus 3 over 6, which is half, and then plus 5 over 6, then goes on like that, plus 1 over 3k plus 1 over 6 to give us 20 and 1 over 6 as an improper fraction, 121 over 6. From here, our first term, a is equal to 1 over 6. Then d, you say 3 over 6 minus 1 over 6, you get 2 over 6, which is 1 over 3. Even here, if you say 5 over 6 minus 3 over 6, get 2 over 6, which is 1 over 3. Right, and then n, number of terms. You'll see the importance of doing this, number of terms. I say top number minus bottom number plus 1. So it's k minus 0 plus 1, which becomes k plus 1. So the number of terms is k plus 1. Remember, we want to find the value of k. Right, now let's do our calculations. Sn is equal to n over 2, 2a plus n minus 1 d. Right, and then what we do here, let's substitute what we have. Our Sn is 121 over 6. 121 over 6 is equal to n over 2, then 2 times a, 1 over 6, and plus n minus 1. The difference is 1 over 3. Okay, Right, let's multiply by 2 on both sides of the equation. This gives us 121 over 3, and then n, and 2 times 1 over 6, that is 1 over 3, plus 1 over 3n minus 1 over 3. Right, 1 over 3 minus 1 over 3 is 0. So we remain with n times 1 over 3n, which is 121 over 3 is equal to 1 over 3n squared. Right. We have the same denominator here, so we can just equate the numerators, or if you want, you can cross multiply. You will get that 121 is equal to n squared. Okay, since the denominators are the same there, so equate the numerators. You can use difference of two squares. 0 is equal to n squared minus 121. 0 is equal to n minus 11, or n plus 11. N is equal to 11, or n is equal to negative 11, but n should be a natural number, so n is equal to 11. But now we're finding k, and then say the number of terms is k plus 1, meaning that k plus 1 is equal to 11. So it becomes k plus 1 is equal to 11, and then solve for k. K is equal to 11 minus 1, which is 10. So don't forget to